Hi, we make this short video to demonstrate how we've used building information modeling on an interior design project. And this video is targeted to CAD managers, quantity surveyors, designers, contracts teams who are working at the construction design phase of an interior design project. So they are making construction drawings, fabrication drawings, and construction drawings for approval by clients. They are making bill of quantities or checking bill of quantities against purchase items, making procurement schedules, and so on. Interior design can be split into three parts. The first being the design of wall finishes and wall paneling. The second being joinery items, whether loose kept or inbuilt. And the third is FF&E items, bought out items like sofas and so on. In this video, we are looking at wall finishes and wall paneling. In a subsequent video, we'll look at joinery items and how we use building information modeling in them. So to demonstrate the concept or what we've been able to achieve, we have this space here which has a lot of wall panels. Over 2,500 different wall panels if you include the pre-cut stone that comes from a factory, or the water jet cut tiles that come from a factory cut to size. So all of these are treated as individual panels, and there are 2,500 of them. To demonstrate, we will be looking at this panel here. This is a fabric panel with a band of veneer running across it, and with the timber skirting to it. Now the process starts in AutoCAD. In AutoCAD, we draw the first panel in, and this panel is an MDF panel with foam on top and a fabric wrapping around it with brass trims on two sides. And just to give you a scale of what we are drawing, this is the size of the 10 mil by 28 mil. And you'll also notice the precision to which everything here is being drawn, 0.0000. So that's the first panel we make. We are able to manipulate geometries more easily in AutoCAD, so that's why we start in AutoCAD. Then we go back to Revit. We put the first panel in, then we put the second panel in, so on. We realize that this trim here is going to be 25 mil, this is going to be 10 mil on the side, because this panel has to have 10 mil on either side. You see 20 mil in elevation. So you slowly build the thing together. You come to the corner and you realize that you have to do a special type of trim. You go back to AutoCAD, and in AutoCAD you design a special trim. So there's a to and fro process between AutoCAD and 2D CAD and building information model, until you arrive at a stage where you have the full model with all the panels, the different types of panels laid out. You have detailed drawings of a particular panel type, the plans at different levels, elevation, a section. You get a presentation drawing for approval of that particular wall type, and you get an entire plan of that space in 2D, which you can give to site managers. Foreman can measure off this drawing, and they'll get the dimensions of the walls and the panels to the same precision as we'd started working on this. So you get that overall plan with all the panels laid out. You get the approval drawing. You get, most importantly, this model with everything in it. From this model, then you derive the elevations as you've derived the plan. And then you begin to use some of the intelligence that you've added to these elevations and plans. So I have shaded one of these elevations to show you what we are aiming to discuss. This is a typical panel with the fabric, veneer band, and so on. and we've called this wall type 16, so internal wall finish type 16. So you see all of these panels are type 16. Within 16 you will see different types, and this is the intelligence that gets added automatically to the drawing. So these are different types. This is type 4, 6, 7, and they're different because the trims on the side is different. One is mitered, one is 20 mil, another is 10 mil. This one has got 10 mil trims on both sides. This has got a 20 mil trim here and a 10 mil trim this side, and so on. So you get these various types, and then you get some numbers written below these, and these again are part of the intelligence that gets added to them. So this panel, for instance, is 16 or 6. Now from that same model we are able to derive a schedule, and this is again a schedule of that internal wall finish type 16. You see the various types of panels it has. These are all fabric and veneer band panels, but some have got miters on the left side, some have got miters on the right side, and trims of different sizes and so on. And then from that you get this schedule here, and let's look at this item, for instance, internal wall finish type 16, panel type 4. This has a length of this much, a height of this much. There's only one of those in the project. It's 45 mm thick, and if you're pricing anything with surface areas, that's the surface area of it. And it gets a unique identifying number. Now you can send all this information we've discussed so far, this schedule, you can send the drawing, you can send this drawing, you can send the schedule, you can send the overall plan to your fabrication shop, and they will produce a panel and package it with this number 16 or 6, and they'll know exactly what size and what type of panel to produce. They will package it with 16 or 6, and you will know where to put it in your building. So that's one level of intelligence that's been added to this. Another is the socket locations. The electrical and the data socket locations have been shown here, and this is required by the fabricator to know where to make cutouts for all of these things. And at the same time you derive intelligence from them, and you pull out a quick schedule, so you know that you've got 9 numbers of double gang socket outlets, 13 amp double gang socket outlets. You are able to check this against what you've tendered. You are able to check it against what the electrical subcontractor is doing. You can check it against what you're ordering, and you know that this is live information coming out of a model that is being used to build what you are trying to build. So that I hope gives you an idea of how we are able to use building information modeling in deriving construction drawings, a full set of construction drawings that are used at site and used for a lot of other purposes, from ordering to cross-checking and so on. I hope you find this useful. Thank you.